Oh, yes, we've got 24. We can get through everybody popsicle sticks. So this is Unit 2, Day 4. So the first thing is you've got to remember all those trig rule things, or the unit circle things. So this isn't derivatives. This is just review your known, right, quote, known, hopefully, trig values of angles on the unit circle. So let's see how quickly you can get through those. So those are the answers. If you're watching at home, you can hit pause and check them all. All right, we're not going to do the exploratory calculator activity because it takes too long, and because we may have done it last year. Speaking of last year, do you remember what the derivative of sine is? Derivative of sine. It's cosine of x. And the derivative of cosine is negative sine. Good. Got to know those. Box them, star them, highlight them, whatever your favorite thing to do to box off things that you got to know. And you got to memorize. Like, a lot of times you can figure stuff out. Like the unit circle, you know a few things, you figure out everything else. You just got to know those. Derivative of sine is cosine. Derivative of cosine is negative sine. Okay, so here's the box of all 6 trig functions. So we just did sine and derivative of cosine. Did we do all of these last year? Yes. But then I'm going to ask the next question. It's going to get real quiet. The derivative of tangent? Is secant squared. And what you might remember, what I hope you remember at least, is that there's a pattern going on. So if you remember the derivative of tangent, you can probably figure out the derivative of cotangent. Like the sines and cos trade places and it becomes negative. So it's negative cosecant squared. Anybody remember the derivative of secant? Secant tangent. Which means the derivative of cosecant then is negative cosecant cotangent. So you got to know all 6, but most people sort of focus on those main 4 because, well, first they're more common, and then secondly, if you can remember those 4, you can figure out the trick to get the ones that are a little bit weirder. You don't see those as often, but again, when you see them, as long as you know everything else, you can use the pattern to come up with them. So yes, you got to know all of them, but if you're going to like flashcard or Quizlet or whatever, you might want to focus on those 4. Okay, so number 1, if y equals 2 sine x, then dy dx is, so the 2 is still there, and the derivative of sine is cosine. It's like, that's it. So number 17, g prime then, the 17 is still there, and now I do want to call on some people. Seth, what's the derivative of tangent? Secant squared. And right now, you may still be just looking up at the top, and that's okay, because even the process of writing them down multiple times will help them stick in your brain, we hope. 3 maybe looks weird with over 6, but just put the negative 1/6 out front, and then worry about the derivative of cosine. Aslan, what's the derivative of cosine? Well, be careful. What the derivative of cosine is negative sine of x. Now, there was already a negative there, so I'll give you the benefit of the doubt and assume you multiplied the 2 negatives. Number 4, it's just more of the same stuff. So y prime equals derivative of secant, secant tangent. Derivative of cosecant is negative cosecant of x, cotangent of x. Minus 1/3. Derivative of cotangent is negative, so I'm just going to make this negative positive cosecant squared of x. Like that's you're just using the rules. So the practice problems, I don't know how much it helps, because you just got to know the rules. And if you know the rules, the practice problems are easy. Number 5. Do we need to do all of these? I'm going to say no. Let's do, let's just jump to 8 and 7. Somehow they go backwards. We'll skip 5 and 6. F of x is 6. Secant x, find f prime of pi over 6. F prime of x would be 6. Derivative of secant, again, if you don't know it, it's at the top of the page, and for now that's fine if you just look at it and write it down. Again, the process of writing it down will help you remember it. So, derivative of secant, secant tangent. But I'm not done with this problem. What else do I need to do? Plug in pi over 6. 6 secant of pi over 6 tangent of pi over 6. And speaking of fun safe stops, if you thought leaving a square root in the bottom was wild, you're allowed to leave that. So on a free response question, careful how I word this, on a free response question you don't have to know trig values, because you can just leave that as your answer. Now on a multiple choice test, where a problem that straightforward is going to be a multiple choice question, there's no way that that's going to be the answer. They're going to expect you to know your unit circle, to do a little bit of algebra. Let's see, pi over 6 is right there. So the cosine is root 3 over 2. So secant is 2 over root 3. Tangent of pi over 6 is root 3 over 3. So, actually, that's kind of nice, because the root 3's will cancel. And then 12 divided by 3 is 4. Again, that's going to be your multiple choice answer. So, free response questions, you can leave safe stops. Usually because, and especially in a free response question, there's so much more going on in that problem, and we're not worried about you knowing those values. We're worried about all the stuff that led up to that. All right, let's skip number 7, because it's the same thing. Take a derivative, plug it in. So I don't want to blow through those like they're not important. It's just practicing doesn't really do much until you know these things. So you've got to know those. Hopefully you remembered a few of them from last year, or at least they look familiar, or that getting them back in your brain isn't too bad. Okay, product rule and quotient rule. We learned in previous sections that the derivative of a sum or difference, so adding or subtracting, is simply the sum or difference of their derivatives. So like you can, I don't want to say distribute, but that's kind of what's happening. You could sort of distribute the differential operator. It'll sound fancy. And the derivative of f plus g is the derivative of f plus the derivative of g. Like we use that all the time without even thinking about it. Like you're not even thinking about that property when you find this derivative. 21x to the 6th plus 36x squared minus 17. Like you use that property without even thinking about it, because it's a property that makes sense, which is nice. Now the trick is, if it would work for sum, will it work for a product? So it works when we're adding, but the short answer is no, it does not work for product. So you cannot do this And that's going to be the most frequent common mistake people make, is like they're going to remember the derivatives of the pieces and like feel relieved that they remember them and then just multiply them together. But you can't do that. If you want to find the derivative of a product, you've got to use the product rule. And here it is, like with lots of primes and parentheses. There's maybe a shorter way to write that. The derivative of f times g, so this will be how you remember it. You won't remember all the parentheses. We did this last year as well. It's the derivative of one of them times the other, plus the derivative of the other one times the original of the other one. And since it's all multiplication and addition, like the order doesn't really matter. As long as you grab one derivative and one original and add it to the other combination, that's the product rule. So f prime g plus g prime f. And again, there's not 100, but there's probably 4 different ways to write that. Because addition and multiplication, you can mix things up. One derivative, one non-derivative, plus the other way around. Let's do some examples for this. F of x equals this mess. So the derivative, thank you. Let's do the derivative of the first one times the second one plus the other way around. So the derivative of the first one would be 4x cubed minus 6x plus 9. This is going to be a long, ugly answer here. Okay, that's the derivative of the first one times the second one. So don't do anything to the second one. Leave it alone. Plus the other way around. So you got to kind of keep track of, well, which derivative did I take? Which one did I leave alone? Now do the other way. So the derivative of the second one, 10x to the fourth plus 4x cubed, times the original of the first one, so don't do anything to it, x to the fourth minus 3x squared plus 9x, and no way do I want to multiply that out, and no, just leave that alone. Alright, then we start to change things up a little bit. First with our wording, but instantaneous rate of change, we know that just means y prime, derivative. And now I've got an x cubed and a sine of x. I'm going to slow this one way down and know that you're not going to do this very often, but sometimes it's helpful. So the first term is f. So f prime is 3x squared. Second term is g. The derivative of sine is cosine. But the benefit of slowing it down is now it's easy to give your answer because all your pieces are already there. So like do all the thinking in one step and then do the assembling in another step, rather than trying to do it all at once and kind of getting lost on where you are. So we did derivative of the first times the second. I always end up with like a crisscross thing. If you write them in this order, then it's always one diagonal plus the other diagonal. X cubed cosine of x. Some students will never do that. They'll just kind of do it all in place. Derivative first times the second plus the other way around. Other students will always do that because they want to like force their brain to slow it down rather than trying to remember all the, remember the basic formula and the individual pieces. Like that's a lot of stuff going on. So it's up to you. Usually I'm kind of in the middle. If it's an easy one, I'll just do it in place. If things get kind of crazy, then I'll slow it down and find the pieces and then assemble it. Number 3. Number 3's got a 6 on there, and that sometimes throws people off. So it might be helpful, even if you don't specifically take the time to write it all out, to at least sort of group them so that you know which one is F and which one is G. I'm going to go back to not writing everything out, because I know it's the derivative of the first times the second plus the other way around. So derivative of the second is secant squared of x times the first, 6 sine of x. That looks a little bit weird with the 6 right there. It's not wrong, but on a multiple choice test, it's probably going to be put that 6 in front just because it looks better there. So I'll box both of them. They're equally acceptable, but multiple choice answers are going to be cleaned up. You just don't have to clean up free response answers. Oh, yeah, thank you. When x equals pi over 3. I'm betting on a multiple choice test, this would not be an answer. So if you got there and then looked at your choices and they were all just numbers, you'd be like, wait a minute, what happened? And then realize, wait a minute, I'm supposed to plug things in. 6 cosine pi over 3 tangent pi over 3 plus 6 secant squared pi over 3, and I'm out of room, sine of pi over 3. Cosine pi over 3 is a half. Tangent pi over 3 is root 3. Secant of pi over 3. Well, the cosine of pi over 3 was a half, so the secant of pi over 3 is 2. And then 2 squared is 4. And the sine of pi over 3 is root 3 over 2. Oh, and remember, you don't have to evaluate if it's free response. There's your safe stop. Don't mess with it, don't mess it up. But you're very rarely going to be able to have that as a safe stop. It's going to be a multiple choice question. So 3 root 3 plus 24 over 2 is 12 root 3, which would be 15 root 3. Unit circle, unit circle, unit circle. Let's skip number 4. It's the same process. Derivative 1 times the other plus the other way around, and then plug in 2. Okay, quotient rule, a bit more complicated than the product rule. Let's write the product rule up here one more time, just to kind of have it to compare to the quotient rule, and writing it down one more time helps it stick in the brain. So derivative of the first times the second plus the other way around. All right, well, division is more complicated than multiplication, so maybe it makes sense that the quotient rule is more complicated than the product rule. F prime g minus g prime f over g squared. The big thing about the quotient rule is because it's a minus, you got to get the order right. Like the product rule didn't matter because you're adding. And so there's really no such thing as getting the product rule backwards because it's addition, so it doesn't matter. But if you get the quotient rule backwards, you're going to be off by a sign. And you can almost bet that every multiple choice question, you're going to have an answer of 3 and negative 3, because if you miss the sign, you're going to get one of those two answers. So the big thing with the quotient rule is figuring out which one goes first. And I'm going to write it this way and then tell you how I remember which one goes first, if you don't remember what I said last year. Gf prime minus fg prime over g squared. I use this line every year, so I don't know if you heard me say this last year, but the girls usually have a much easier time remembering the quotient rule than the boys. Do you remember why? something about probably sexist to say it, but if you want your relationships to work, it's the same thing as making the quotient rule work. You have to keep the GF first, right? And that's why the girls remember this rule better than the guys. Sorry, guys. It's consoling each other. I don't know what that was. But yes, that's the silly, dumb way to remember which one comes first is, remember, GF prime minus FG prime over G squared. Again, make some silly deal out of it, but that is the main thing that people mess up is they know it's one of them times the derivative of the other, and in product rule it doesn't matter, but in quotient rule it does. So whatever it takes to remember to keep the GF first so that the quotient rule works. GF prime minus FG prime over G squared. Okay, enough of beating that dead horse. Let's try an example here. And this one, for quotient rule, I will frequently label the top F and the bottom G, and find the derivative of the top, and find the derivative of the bottom, and then put the pieces together. Because it's the product rule is easy enough to kind of do it all at once. The quotient rule is like, there's a lot going on. Let's slow this down. So F prime is 5, G prime is 2x. Now I've got all the pieces. Then I can look at the quotient rule and put them together. So GF prime would be 5 times x squared plus 1 minus, you still have this crisscross thing going on, minus the other way around, FG prime, 2x times 5x minus 2, all over the square of the bottom. And yeah, that's a safe stop. Multiple choice might clean it up a little bit, but safe stop it, also okay. Let's do, you know what? Let's work on our algebra here, because 5x squared plus 5 minus 10x squared plus 4 all over the denominator. So negative 5x squared plus 9 over x squared plus 1 squared. Multiple choice answer versus free response answer. Uh-oh, did I mess something up?
You said plus 9, it's plus 4x.
It's plus 4x, it sure is, which messes this up. So plus 4x plus 5. How about that? Yep. And that's why we do those, to make sure our algebra is okay. I messed up distributing the 2x. Right, now it's good. But that also, I didn't do that on purpose, but that also illustrates why if you have the chance to leave it as a free response answer, leave it. Like, do I know how to distribute? Yes. Did I mess that one up? Also yes. Number 2, find the instantaneous rate of change. Again, fancy words for find the derivative. The top's F, the bottom's G. F prime, G prime, and then put them together. Why don't you try that one? So as you can see, as I perfectly did, 2x cosine x plus x squared sine x over cosine squared. There are a few people who don't show their work on this. It's too much for me to keep up with the derivatives and the quotient rule like all at once. I will almost always show my steps on this. If you don't want to, that's up to you. All right, why don't you try number 3, although this one you're going to have to plug in pi over 3. All right, let's do the last one because in some ways it's easier, but because it's easier, it feels different and trips people up. The top is F, the bottom is G. What's F prime equal to? 0. So that's going to make life easier, but somehow that throws people off when you get a 0 in there. I mean, again, it simplifies things. So see if you can finish number 4. So we make it this far, and then we plug in 2. Again, be careful with your labeling things. H prime at x versus H prime at 2. Those are different things. So again, label them appropriately. That would be a safe stop. It wouldn't be the final answer. If I do 16 times 16, I'm going to have to reduce. I think I'm going to write out 16 times 16, which maybe seems weird, except that I can reduce 4 and 16 to just 4. And then 4 times 16 is 64. So I don't know that everyone would have done it that way. 16 squared is 256, but then you have to reduce with 256, so whichever. The bottom stuff down here is just notation. There's dy dx is f prime. If you put a squared on it or a 2 on it, it's double prime, triple prime. After 3, you stop putting hash marks because that would look kind of silly to do f 1, 2, 3, 4. I guess people would know what you're doing. But we'll put a 4 in parentheses. That's not f to the 4th. That's the 4th derivative, the 5th derivative, and so on. All right, so again, today comes with 2 worksheets. Worksheet 4 is trig stuff. Worksheet 5 is product quotient. And kind of up to you as to when and how you want to accomplish all this. There's still 25 minutes left, so you could knock out. You could probably finish the trig worksheet. Thursday's assignment. What did we say Friday's assignment was?
Nothing.
Nothing. I'll say nothing new. Maybe something old in there, like worksheet 4 or 5.
Okay.
So, McKenna, let's do some of worksheet 4 today.
I think she might be.
That way, you don't have to worry about it
I'll do it.
later this weekend.